All right, good afternoon, everybody. Thank you very much for coming across to get this thing started. We have a chalk talk today on sensors and location. My name is Fred Bisogna. I'm a lead program manager on the Windows team, and I work primarily as the lead program manager for sensors, location, portable devices, and a few internal buses. I'm also joined by my colleagues today, Sandy Spinrad. Sandy, if you could get up for just a second, please. Sandy will be continuing the talk for the latter portion over here, showing about testing and validation and some of the tools that we have. We also have Dino, who is the program manager, and you've probably met him quite a few times here on location, and Gavin, who's giving a number of talks today on sensors. The purpose of this chalk talk today is to have a short recap of all the information that we shared in the earlier sessions for anybody who wasn't able to make it. And then we'll follow it up with Q&A, chalkboard sessions, and also show you some of the tests and tools that we have created. We'll try and cover the content of the information in the first 15, 20 minutes, and then we'll leave a majority of the portion for a Q&A. So that is the main intent of this chalk talk over here. So with that, let me go ahead and get started. The agenda, as I was discussing, is around sensors and location opportunities. You've seen a number of these already showing up on the slate that you have. Take advantage of the things that are in there to build the applications. From the applications, we'll start drilling deeper and deeper and deeper. We'll start going into the platform and how you can actually tie in to the platform. We'll show some demos, or one demo primarily of tools to help validate some of the things off the platform. Data from both applications, as well as data being provided by the sensors themselves. And finally, we'll end with validation of the kinds of things you should watch out for when you're building one of these systems. As Gavin mentioned earlier, they're not very easy to build at times. There are little nuances that you have to pay attention to always. So we'll try and share some of the best tips and tricks that we found out ourselves. What will you leave with today? The biggest thing is, of course, the takeaway from everything we've discussed today on sensors and location. But most importantly is every question that you have over here that's pertinent not only to you, but to everybody else in the audience. Ask us those questions. We've got a board. We will use it if necessary. We also have the Ask the Experts that will follow immediately after this from 5:30 to 7. I think it's in Ballroom B in the main hall. So if you do have a question that you don't feel is pertinent to the audience, or you don't feel comfortable bringing it up over here, please feel free to get hold of any of us at Ask the Experts. So with that, let me go and get started. We discussed a little bit of the opportunities that are there for sensors and location applications. Location was one of the primary use cases that we talked about at a high level. We showed some of the ways it will be used. I'll recap that in just a minute. Same thing for sensors and how you can use your apps to naturally get information from these sensors to adapt to the user's environment. The main reason for doing this is users dislike having to press extra buttons or spend time in changing the display settings for their brightness or attaching something to play a game. Let's make this as seamless as possible. To achieve that, as we were talking about, we broke it into 3 categories of applications. The really simple gestures for certain applications. Think of it like the shake, rattle, and roll. Those 3 gestures are your flip, your rotate, and your shake. But along with that, you can also go ahead and take advantage of some raw sensors like your accelerometer for the Labyrinth game that a lot of you have played. And you can take that raw data and do some smart things with it. But it doesn't stop there. Every raw sensor has flaws or error zones that we call. And in those error zones, you actually could use the data from the other sensors to compensate for it. Sensor fusion is the object that is finally shared with the application so that you can do some smart things without having to worry about those error zones. Sensors. Very high level, we break them up into 3 categories. The first one is the light sensor. That was the first sensor we actually introduced in Windows 7, and we have done innovations on top of it in Windows 8. The next sensor is the motion sensor, or the set of motion sensors with Fusion. And the third one is the presence sensor. I know a few of you asked questions on this. We haven't gone into a lot of details yet is because we have to do some more investigation studies on these ourselves. But the scenarios that I was discussing just a minute ago can really be broken into these 3. The basic ones are places where an application just wants to register for data. It just wants to be told something has happened, give me the data, I'll take care of it. It would be boring if every application had to go and figure out, has the slate been shaken? We do that for you with the help of the display drivers or firmware in some cases. And we give a notification to the application saying, your device has been shaken. Do the right thing with it. If you're a media player application, you may want to just shuffle the playlist, as an example. The next thing, as I was mentioning, was the intermediate apps. Spoken enough about that. And the last one is sensor fusion. Sensor fusion is one of the huge innovations that you've heard us talk about today. I do have some more details, and we will spend some time on the chalkboard if you have questions on that topic. But along with sensors, there's also location. And location scenarios are broken into two fundamentally different areas. The first one is a single-shot location. I really only care about where I am when my app starts up. And with that information, I can do some smart things about what I display to the user. It's a single-shot event. We keep reiterating it's a very few lines of code, 3, 1, 2, those are the numbers you keep hearing, but that's what it really is. But apart from the single shot, you also have event-based notifications. Event-based notifications help you do a few different things. If you move out of a particular zone of interest, you just want to be notified. Just shoot me a heads up that I've gone more than a mile from this location and check me out. Dino was actually, when he was selling me on this technology back in the day, he was explaining to me how he had gone to have lunch, I believe, at a particular restaurant in Seattle. He had checked in on that particular website that he was using, and a few days later, he was still checked in having lunch at that particular place. So, not that I want to state anything about it, but an app should be smart to register for notifications saying, when I'm more than a mile away from that restaurant, it's highly unlikely I'm still having lunch over there. So do something smart, log me out. The other examples of event-based notifications could be turn-by-turn, driving directions, etc. So what we do is, of course, support W3C APIs. Those are paramount to us. We have provided support starting with IE9 for those APIs already. But in addition to that, we have provided the Windows Runtime APIs that go through and add additional details and smartness that isn't available today in the standard. The threshold is one small example of that. So now that I've started talking a lot of these examples and you've heard it, how does it actually flow through the platform? So what you have over here is you've got the, let me try and see if I can get the laser pointer going. You've got your Metro-style apps that are running at this level right here. What they do is they actually use the runtime API set for sensors. In this particular case, I'm talking about sensors. The runtime APIs simply build on top of the regular Win32 API set. You have seen some of these APIs with Windows 7. We've gone ahead and extended those APIs for the new sensor categories also for Windows 8. And that is why you can go ahead and build a regular application on top of the same API set. Now, what we did was, this API set that you see here is actually your level of division. And what we started off with in Windows 8 was that whole chicken and egg problem of who's going to create all the providers for sensors for us if there are no applications sitting on top. And the way we broke it up was in two parts. We created some basic experiences at the top level up here to take advantage of certain key sensors. And along with that, we created certain class drivers at this level right here to provide that data. So providing some innovation and incentive for our partners to start working in this ecosystem. So as I drill further into the stack, what you see is two different drivers here. This particular one is the sensor HID class driver. It's a class driver that we've worked with the industry, with the help and support of a lot of members in the industry, to actually create a simple way of enumerating what is on your sensor, defining the bits, and sending it up. It is a very low overhead protocol, and it is scalable across multiple different buses. I'll get to that in just a slide further. But apart from that, you also have the ability to write your own existing sensor drivers. And the reason for doing that is there's a lot of hardware that is already in the ecosystem or innovation that people want to build on top of the class driver at times. So we do allow for both of these situations and conditions here. So as I mentioned to you, the class driver, well, actually, it's not just one. There are two. The first one that I spoke about is the HID sensor class driver. The buses that it supports, of course, USB. But apart from that, some of you in the crowd, we've had discussions on this, is support for I2C. What we noticed is a majority of the sensors are often connected or support I2C. And we wanted to come up with a simple way of allowing you to take those sensors, connect them to your system without having to provide additional drivers. So at Microsoft, we created a protocol, which we're sharing with the industry here, to enumerate devices, take the data from those devices, and encapsulate it over I2C in HID packets. The sensors that are supported by HID I2C are the light, the motion, and the presence sensors. Those are our tier 1 sensors. But a few of you also asked the question, what about the other sensors? We have more. It's more than just the light sensor or the presence sensor. What about the rest of them? I was told by my team that we actually support about 20 different types of sensors using this class driver. There's support for even things like temperature and things like that. But what we have done is, though we support it in a class driver, since we don't know how people will use those in applications, we haven't gone through and put them in the Windows runtime yet. You can, of course, build a regular application that uses Win32 APIs to communicate with those particular sensors. Apart from the HID sensor class driver, we still have the ACPI driver. The purpose of the ACPI driver is very simple. It's built on top of the Windows 7 foundation, and it uses simple ACPI methods in order to get the data of the ALS and then pass it upwards to the stack. There is more work that the OEM partners who are building the systems need to do for these devices, and it does create a little bit more work in the embedded controller and firmware in the embedded controller that has to be written for this particular class driver. It does support only light. It's, again, only for ALS. And it does rely on the ACPI 4.0 standard. So as you go through this from the application further down through the stack to the driver, the fundamental piece that is required to make sure that the applications have a rich experience is the actual hardware. So what we are recommending is for the Windows 8 systems to have an awesome experience with applications, that these particular sensors and GPS, especially on systems with mobile broadband, be recommended as the hardware that is present on these systems. You probably heard, you've probably seen it on the systems that you have, and that is what you should expect to see. What Microsoft also does is we make sure that the systems, irrespective of which sensors and from which manufacturers they are on, the systems behave in the same way. So if your application is written once, you don't have to configure it for every different system that you get for Windows. So that's a hard task. And the way we go about doing that is with the tests and the tools that we are creating. We've got our test lead over here, Sandy Spinrad, and I'm going to ask him to go into some more details of the hardware and the software validation over here. So Sandy, if you can show us some stuff.
All right, thank you, Fred.
Thank you.
Hi, everybody. My name's Sandy Spinrad. I'm one of the test leads in Windows. How's everybody doing today? Good, good. How's everybody liking the Nike system? I'm sorry. Strike one already. All right. How is everyone enjoying the Samsung developer preview systems? Cool, cool. Anybody running into any problems? Anybody seen our new blue screen yet? No? Okay. A little frown? Oh, so we have one. So if one of the things that my team's responsible for is really what our goal is really is to find the bugs and find the issues in the systems before we ship, and both in our software and third-party components. So we're all about driving quality into the system. That's really what my team's missions are. My team's primarily focused around the sensor scenarios. So what I'm really glad, really excited to be here today to talk to you and start off the discussions working with you about how we can drive quality sensor experiences into the system and into our platform. So one of the tools that we have to drive quality in the system is our certification process. This was previously known as the Windows logo process, which many of you are probably familiar with, which has now been, we've now renamed this into the Windows certification process. So some of the recommendations I have for you is to make sure, especially as system manufacturers and the IHVs for that matter, is make sure you understand the new certification requirements. I've been at Microsoft now, it's getting up around 17 years. So one of my first and most exciting experiences was shipping Windows 95. And there's three things I remember about Windows 95. The first one was the big circuits tents being set up in the soccer field. And we really did have circuits tents set up in the soccer field. The second one was seeing a poster board truck. I think it was sponsored by one of our competitors that spelled out "congratulations" without any vowels, C:/. Right? And the third thing that I was really excited about, well, not so much excited about, but a little bit shocked, is shortly after I went to the launch party, I had to go buy gas for my car. And at the gas station, they were selling Windows 95. So that's the first time I've ever saw a software product at a gas station. But yeah, I don't know if that was just local to the Redmond area, but they were actually selling Windows 95. So what does that all have to do with sensors? That was a really big, exciting event for me. And over my tenure at Microsoft, I've been through a few exciting events. But what I'm seeing in the buildup and the excitement I'm seeing in the number of products, and like the number of people downloading the sensor demo applications, is I think we're on the foothold of something really big again. I think we're going to see sensors applications. This is going to be one of the big hot new things that's going to be in Windows 8. And so that gets me excited. Actually gets me a little bit nervous too from a quality standpoint, because that means I'm really dependent on working with all of you and together to develop quality experiences and robust experiences with sensors. So make sure you understand the sensor requirements, because it's that's really the understanding, that's really the starting point, to understand the requirements, to make sure we have a consistent experience with our users have a consistent experience using sensors. There's been a couple occasions also in my tenure where some vendors didn't quite understand the experience, and it was really late in their development cycle, only to find out that they got around to running the then logo test, and they had a failure, and they were really missing something in their design. So one of the lessons that I've seen, and I want to share with all of you, is make sure you're not one of those vendors that you're like a couple weeks from shipping, and for the first time you run the logo test, you find out you have a design shortcoming, because that's a really painful situation to be in. The other kind of caveat that I want to give you is that the certification tests that we currently have planned are probably going to be somewhat limited. They're really designed to make sure that all the required sensors are there, that the sensors are correctly orientated. We typically want to avoid having an accelerometer orientated upside down, because when you press that rotation lock, you don't want to see your screen flip. So we'll catch that. And we're looking to make sure in the test that the sensors provide the correct data fields. So what I'm looking to you is to put some resources and plan for putting some resources really into doing some extensive testing around the sensors that you're developing. And for system manufacturers, we really have to look at all the sensors and really think about developing a test plan for every sensor that you have in your system. Of course, sensors are devices, right? So pay attention to the normal problems that devices run into, especially around power management, plug and play. Sensors are a little bit more susceptible to some unique conditions, such as noisy RF environments, maybe some stress. If there's a lot of activity that's going on in the system, you might have a new electromagnetic field. I don't quite understand all this stuff. I'm a software guy, so I rely on you guys, the hardware experts out there, to explain what that means. But that's some of the experience that we've seen on the early prototype systems. We ran into this. So we want to test in a variety of environments and lighting conditions. And be sure to use the common verification tools, and those have been discussed and previous sessions, both here and years past. The common ones are the Windows Driver Verifier. We have a special one for WDF drivers, and all the sensors are built on top of WDF, so you want to make sure you turn on WDF Verifier when you're running your tests, and Driver Verifier and Application Verifier. And so with that, I want to show you a quick demo of a tool that one of my colleagues developed, and really he did this in his spare time. Yeah, I think he did it over a weekend. Excuse me, I have to log back into the system. All right. Okay, so here we have a tool. Yeah, good. It's still running. Here we have a tool that, like I said, a colleague of mine pretty much on a weekend threw this together, and it's just a few hours worth of work. And to show you, this tool is probably a little bit more exciting than watching paint dry, but not too much. Let's see, let me turn on the accelerometer. Oh, okay. Well, getting back to, what did I say my role was? Finding bugs. This is one of the known ones that we have here. One of the problems we have coming out of sleep, which my system did just go to sleep, is that we have to restart our application. So basically, as you've heard, I won't lie to you, wasn't quite 3 lines of code to read data from the sensor. Let me switch to the code real quick. To actually get data from the ambient light sensor, it was more like 6 or 8 lines of code. I'll just walk you through that real quick. Find my mouse. The first steps that we have to do in the code, we just basically initialize our display surfaces, variables, grab our sensor. That's a big one-line piece of code. Make sure everything's all okay. And reset our display surfaces to what we want them to be. And then register, I skipped that. Make sure we register for our callback right here. So when we actually have a new lighting range change, provided we haven't hit the bug that I just hit, you'll have your callback that gets called right here, and which then here's our big complicated piece of code that reads the data from the sensor and then simply goes ahead and updates the control, and it's displayed on the screen. So as far as sensors goes, there's 4, 6, 8 lines of code to be able to read data from the sensors. So what does this mean from testing? So what I could have done, or what I encourage all of you to do, is take this very simple piece of code, right, put it in a loop, right? So you're constantly opening and closing that handle, right? So you're exercising code path both in your driver, if you have one, or you're actually exercising code path on your firmware, because you will see activity all the way down in firmware as an application opens and closes the handle to receive data out of the sensor. Put that in a loop, right? Have that run over and over and over again, right? And then do something, right? If you had, in the case of the ambient light sensor, maybe hook it up to a flashing light, right? So you have a flashing light, you have the sensor opening, the data coming and going, and then run one of the tools that put the systems in through either a cycle of power states or a cycle of plug-and-play events. And now, in probably about 2 or 3 hours, you have a massive stress application. And we have you get that running. I think you'll find initially it doesn't run very long. But when you get to the point that stress application runs for days on end, then you know you have a solid experience and something that our users can rely on. So some of the other lessons that we learned in working with companies developing the prototype devices that we've seen so far, one of the critical ones, not so much critical, but more of annoyance ones, is ALS placement. Our recommendation is for the ALS to be centered on the top of the screen. And the reason because of that, users are less likely to go around doing this kind of stuff, right? They're more likely to hold the tablet here. So you want, good catch, right? Good thing this is the last talk that this is being used for. 2 hands, right? You will probably want to avoid ALS on the sides, right? Because this is going to be a common spot for users to put their hands on. And since ALS is driving the brightness of the screen, it'd be pretty noticeable to the user if they actually covered up the ALS sensor and the screen went dark. So avoid that. Another big one, and this is going to be a challenging problem. Again, I look to all of the electrical engineers out there aspects, is the magnetic interference, especially with the magnetometer. I think everybody's going to be up for a pretty big challenge here, right? And all the devices I've seen, including a lot of the shipping cell phones that we all have, smartphones that we have, it's really difficult to get a reliable compass. So you really need to think about really early in your design process, how are you, or where are you going to put, or how are you going to put the magnetometer in such a way that it's not going to be impacted by other components on the system. I think that's going to be a real big challenge. And we want to have a reliable magnetometer because that drives the compass, which drives the orientation sensor, right, which hits that virtual reality experience that Gavin demonstrated earlier that we all want to achieve. Another thing to think about is calibration. Ideally, we want the sensors to be self-calibrating. We want to discourage the need for users to run some special application to constantly recalibrate their sensor. So think about what you can do to either during the manufacturing process or dynamically recalibrate based off of some kind of sensor fusion algorithm to keep the motion sensors or light sensors or any other sensors calibrated. GPS. Here we have a unique problem here as well, right? Now we're getting, as we get into the tablet form factor, it's much smaller than what a conventional either laptop or desktop PC. But we have 5 radios in it, right? And some of them don't have, a GPS signal is pretty weak and definitely susceptible to interference from the other radios. So think about that. Again, this is a real tough problem, way beyond what I know how to solve. But really think about where we're going to put the antenna for all these 5 radios that we're going to put into these systems. And be aware of our RF interference. The key point that Gavin kind of mentioned in his second talk is that we all got to work together, right? These are some tough problems that we have in front of us and some really big opportunities to get it right when we do get it right. To work together, it's communication between all the component manufacturers that we're finding out is really critical. Is that we can't just start slapping components on together and hope they work together because everything is in so close proximity and it's subject to one piece interfering with another piece. And those were some of the things that we've learned so far on the prototype systems. So that pretty much concludes our talking part. Some of the related sessions for those of you, if you missed Gavin's first 2 talks, they have been recorded, so you can go ahead and catch those. It will be made online, I think, in the next few days. There's the talk on the certification program tomorrow afternoon. That's HW260. And so with this, I think we're going to go ahead and open up to questions. So what we'd like to ask you to do is to actually step up to the microphone so we can record that. Or if you prefer, we can take questions sitting in your seat, and we'll go ahead and repeat it. But it's a little bit difficult for us to see up here because of the lights on us. So I would like to invite our other members to come on up and to take questions and be ready to answer questions. Yes.
I'm gonna be the test guinea pig here.
Okay.
Okay. Does the unit we have from Samsung have a Surf 3 chip, full GPS, or is it only GPS? Meaning you're getting your data directly from the AT&T carrier.
Okay.
Did I say it too fast?
Right. Actually, the GPS has been disabled in the Samsung system. We ran out of time to get it working reliably.
Any time frame?
At this point, we do not have a time frame to get that fixed.
Is that like a software update, 6 months, that maybe you can just give it to us and then it mirrors series?
We wanted to do our best to get it up and running, but unfortunately we couldn't right now, so we're not working with
So is it okay to say it's possibly hardware?
Pardon?
Is it okay to say it's possibly hardware related then? In other words, it sounds like this unit will never have a full GPS.
Well, we'd like to discuss that with Samsung and see if this is something we want to support in the future in the form of an update. But until we have that discussion with them, we don't want to comment on that topic.
Yes, okay.
Thank you. Any questions on the tools, the stack, anything we can help answer right now? Yes, please. Do you mind coming up? Or if you
All right.
prefer to sit there, I'll repeat.
I'll project. How's that?
Thank you.
What responses or what events will Windows handle from all the various sensors? Is it going to respond to those events? Of course, rotation. But with all the other sensors, it could do much more. Or is this just an application asset?
Good question. I'll just repeat it for everyone in case they didn't hear it, and for the camera. So which sensors does Windows respond to with some kind of an inbox experience? I think that's your question.
Right.
We try and break it up into 3 different sensors or categories of sensors. For accelerometer, we do use it for rotation. So what we want to do is, as you go from portrait to landscape, we use the accelerometer to detect that. We do have a rotation lock button. A lot of people prefer reading it at odd angles, as I call it, and they don't want the screen to just keep rotating on them, so we have a lock button for that. Secondly, we use the ALS, the light sensor, and the inbox experience that we have with that is the automatic brightening and dimming of the screen based on whether you're indoors in a dark condition, or outdoors in a very bright condition. The third one that we have is location, and for location, we just try to actually make it more available to web-based applications through IE. And along with that, of course, you have the plethora of apps that can take advantage of the individual sensors.
Do you consider haptics a sensor or no?
At the current point, we have looked at haptics, but we're not talking about it in this conference right now.
So
While it is a sensor, for a lot of the Slate form factors, we're not considering haptics right now.
Thank you.
Oh,
Well, go ahead.
yes, please.
Yeah. I have a question about the driver stack on this HID over I2C.
Yes.
When you were showing the diagram, you showed 2 drivers that Microsoft writes. One of them was a sensor class driver, and the other was what was it? It was like third-party driver. And no, it was also on the HID portion of it. It was not third party. It was a Microsoft driver. But my question is it similar to what you had for a USB, like HID USB that says?
Yes. If you don't mind, I can
So-
use a whiteboard to draw up the HID over I2C stack if that helps you with your question.
Yes.
Okay. So keep asking your question. I'll just draw it up. Okay, so simplistic picture. I'm just going to draw these 3 block diagrams right now.
Can you turn the board a little bit?
Sure thing.
I think you might want to use black.
Can everyone see it over here? I'll try not to hit you, Dino. Okay, so at the very high level, you've got a class driver for HID that is being used for sensors. What traditionally happens is HID is a bus agnostic protocol, quite bus agnostic, I should say. We support it over a number of buses today, USB, Bluetooth, etc. one of the fundamental areas where we felt we had a gap, especially for sensors, was I2C. So this is the HID I2C class driver that we created. It is not, this driver is not specific to sensors. It can be used for keyboards or mice or other things also. And then what it does is it sits on top of the SPB controller driver that we were mentioning earlier. So in this particular case, you'd need an I2C controller driver for the actual I2C controller chip that would be provided by the silicon manufacturer.
Yeah, and this HID I2C driver, is it a mini driver that works together with the HID class driver?
Yes. You've got HID class right here.
So it is similar to HID USB.sys then
It
in
is
that
a mini
respect.
port to HID class.
Yeah, you also, yeah, you just said that it could be used for other types of devices, and you also mentioned keyboards and mice. But on your diagram, it showed that it was user mode driver, right? And I remember, at least from Windows 7, that it was not a good idea to use user mode drivers for input devices. Well, probably one thing is that. Oh, okay. Well,
might
that
help.
answers my question.
There you go.
Thank you.
Yes. I don't know if we have. So the bottom right corner that you see here, the sensors driver HID, the
Yeah, you
UMDF
see
one.
the UMDF in that corner. That's what
Yes.
confused me.
This particular driver here that you see
Sensor.
is this one right here. To simplify the diagram, we have left out a lot of the stuff
Oh,
that goes
okay.
between here all the way down to the hardware. So to be a very complete diagram, I would need to draw the transport and HID class between here all the way down to the stack.
Well, in that case, I don't understand why you have sensor driver separate from the sensor class extension.
This is actually the entire driver. The class extension is a DLL that gets absorbed, or a module that gets absorbed into the driver to make it compliant with the sensor stack.
Yeah, thank you.
That, again, this isn't a pure driver stack diagram. If I was to draw that, I would probably use up most of the board over here. Percy, I believe you had a question?
Yes, so Gavin in his earlier talk said that when the display was off, you also shut down sensors. So are you coalescing sensor, sensor activity, like the same way you do with Wi-Fi, like just periodically they wake up to see something's different? Or
Good question. I'll repeat the question. Are we coalescing sensor data in order to do power management or when the screen is shut off or in scenarios like that? At a very high level, I'll bubble it up first for power management of sensors. What we want to do is we want to make sure that power is being consumed when there's user activity. Connected standby and scenarios like that help us achieve that. So there are a few basic conditions we follow. When there's an application that wishes to do something with a sensor, it opens a handle to that sensor. As long as the handle is open, the sensor needs to keep providing data. If the application chooses it doesn't need the data anymore, or the application is swapped out and another application comes into focus and that application is suspended, or the system as a whole goes into connected standby, in all those three conditions, the application needs to let go of its handle to the sensor. What happens is that notion of letting go of handles tells the sensor stack, I no longer need these particular sensors, and the driver communicates with the hardware or shuts the hardware off. So what we want to achieve at the end of the day is when there are no applications, having an open handle to the sensor itself, it gets shut off. Will there be coalescing of sensor data? No, there won't. When you are in connected standby or when Sandy's system was off here, the sensors are off. So some of the scenarios that it causes to fail is like, I cannot count the number of footsteps I've walked, but I generally don't want to carry a slate around to count the number of footsteps that I walk.
I can see right away a great application would be to have a screensaver that keeps motion sensor locked, and you don't log in before there's motion. It yells, hey, someone's stealing you.
Yep, there have been scenarios that people have asked for the situations like that. However, for that particular situation, you'd have to keep not just the screensaver, but a whole number of things alive and active. So we could look into that. I'll be happy to answer that one offline. I do have some ideas on that particular one.
Is that true of the GPS as well?
So the question is the power situation that I discussed true for GPS also? So yes, it is true for GPS. There are some provisions that we have been thinking about for a GPS, and I'm sure Dino can go into more details than I can. I'll try and summarize it. But you are allowed to keep certain applications running as locked screen applications, if I understand correctly. And those applications do allow you to take advantage of a GPS. The one that I particularly like is I'm going to a person's house. And just before I get there, I want to read something in an email or just check my mail. So I can just bring my bar. I can have 2 apps running parallel. GPS can still continue to function at that point in time. I can read my email and then switch back to it. So yes, we do have certain special provisions for the GPS there. Yes, please.
So like on the accelerometer, I believe you have an asynchronous callback to pass data back. Do you
Sure.
have anything that to ensure sort of the timing between these events, that there's some consistency across the ecosystem? So for example, I want a long wait, or I need it every 10 milliseconds, or whatever the case may be.
I'll try and repeat your question. I think what you're trying to ask, and correct me if I didn't catch it right, is how do we ensure consistency across the different accelerometers in the ecosystem as these systems are built, so that there's some kind of consistency, majority of times for the application layer. So from one of the things that Sandy has done for the certification point of view is to go for compliance. There are certain basic requirements that you need to have in terms of times, the change sensitivities that you have to support, the minimum time interval that you have to support, and the test will go through and validate those intervals.
I think in Windows 7, you can specify an interval, but it may or may not respect that. So is it still sort of up to the implementer?
Right. What we try and do is we say that there are certain pre-required values that we want to hit. For example, for an accelerometer, it doesn't make sense if the accelerometer can only report values at 10 hertz, just as an example. So we try and lay those down as a basic requirement. Of course, people are allowed to go through and say, hey, I want to build something that can report at 1,000 hertz. But what Windows will do is say these minimum requirement values are what applications should honor. And if an application wishes to be a vertical application specifically for that device, it is allowed to push that device to the limit. Just on that side, we actually have 2 specific kinds of values that we go after. The minimum time interval is what an application usually wants to go through and coordinate with. But there's also a change amount. Like if the data really didn't change by this magnitude, don't waste time on the bus. Don't bother the CPU. Just be quiet. Yes, please.
Can you turn that functionality off? I'm thinking from a sensor fusion driver point of view. I want to get all the data. I don't want to be missing any of it. And I think to kind of build on what he was saying is, it makes the sensor fusion a lot easier when the data comes in very reliably.
So I'll actually speak to that. Get this.
Here.
So really, applications can use different sensor fusion-related sensor objects, and if they're desktop applications, they can set change sensitivity and interval. For the Windows runtime, we have a simplified methodology where you just specify the interval and sort of the rest of the details are handled on your behalf. So an app can, in the Windows runtime, set a short interval period and get frequent data updates. In the desktop situation, apps can set change sensitivity or the interval to specify that sort of magnitude and time sensitivity interaction model. So what we're trying to encourage, just to speak again to the previous question and to tie that in, is that by default, for screen rotation, for motion sensors, if the device is stationary, we're not seeing spurious data events flowing, right? When the user picks up the device and moves it at all, we have sensitivity that's tailored to screen rotation, which is not a very demanding scenario. Once you start up an application that needs more real-time data, which I think is what you're speaking to, 3D games, that kind of a thing, it sets the interval if it's runtime, or it sets the interval and change sensitivity if it's Win32, and then that app, and actually everybody listening to that data gets the data much more frequently. So we want to see minimal overhead and activity when the device is stationary, when no one needs near real-time data. We want to turn up sensitivity and allow for that full fidelity when there are apps that actually use those capabilities.
Thank you. Yes, please, at the back.
Yes, first, you guys have done a fantastic job. I mean, this is a preview. I want to kind of bring it back a little bit. This is a preview item, and it's really good. Do we have any samples? I asked in another lecture about GPS location, whatever we have available, and they said, well, it's not released. We couldn't. I think it was Socialite. It could have been. Are there any coding examples of accessing that AGPS?
Sure. So the question is, are there any sample applications for GPS specifically? And the answer is yes. We actually do have a number of different code snippets for both sensors and for location. For location specifically, Dino, I think you can speak to some of the examples that we have in the SDK that are available today.
Yes, hi. Thanks again, everybody, for coming. You mentioned Socialite as one of the apps that's location aware. I'd also like to mention that the weather app is location aware, and it actually has a different kind of implementation specifically, where in Socialite, what we looked at there, what we're demonstrating is check-in functionality, right? Like we talked about before. With weather, we wanted to show that you can actually put a control in your app and then have the user actually get location data only when they want it. And it's a single-shot lookup. And so if you bring up the app bar, swipe up or down, you'll notice there's a Find City or some kind of target there. It's a recent addition. And you go ahead and it'll find your location. And then the third app, I don't know if you guys have used it yet. We've seen it, and I think Gavin showed it in his demos, is Near Me. It's just a point of interest. And in that application, it's the location access is at app initialization runtime. So again, a different way of doing things. Our interns were thinking about how they wanted to different access patterns. So you have those demonstrations. And then also in the SDK, that's where you get a lot more detail, where we cover C#, C++, JavaScript. You'll have examples on just how to implement our API specifically.
Thank you.
Yes, please.
As third-party sensor driver that works on Windows 7 will continue to work on Windows 8?
Will a third-party sensor driver that is built for Windows 7 continue to build for Windows 8? It depends on the sensor that you're talking about. A couple of sensors actually have newer definitions in Windows 8, like the gyroscope and others that we started to introduce. So the answer does vary. A majority of them should work just fine. If it is a location-based sensor driver, there are a few new things that you have to consider. There is flight mode support that we have got in there. So we do request that the location driver does have support for flight mode also. So that way, if I turn on flight mode, all the radios on the system, whether it's Wi-Fi, whether it's a GPS, whether it's a 3G radio, they all get shut off together. Yes, please.
You mentioned a presence sensor, and would that be running at all when the system shut off?
Good question. The presence sensor is one that we are still evaluating right now. We do break it out into two specific scenarios. Human presence in terms of a longer distance range, and a lid close for a shorter distance range. We don't have any good things that we can talk about it yet, that we are ready to talk about, but both of those scenarios are very important to us, and we are trying to follow up on it. That's what we're trying to see, where it makes sense right now. Yes, please.
On location sensors, folks talk about GPS all the time, but do you have like a three-tiered system like a Windows Phone where you have kind of accurate, more accurate, really accurate? I think you got the gist.
Yep, a good question. The question is basically, how does the location platform provide the right set of data? Because certain things provide data faster than others, but more accurately. The platform as a whole has a number of different providers that can send location information. What the platform does is uses a few heuristics based on time and based on level of accuracy to make a determination which is the best data to provide at any given point in time. So if a GPS has started but is still acquiring logs, but if the Windows location provider already has looked up IP or Wi-Fi and has given this is your location with a 300 meters accuracy or something, that'll be bubbled up to the application right away. Should the application then want more data to be more precise, it can continue listening for it. And at that point, when GPS does have a more precise fix, or we find more Wi-Fi points and we come up with something even more crisp, we can continue to return it. A lot of the single point location apps that we have noticed really don't care for anything less than 10 kilometers. What they really want to know is approximately what city are you in, so I can give you the weather for there, or what is your time zone, or things like that. But for apps exactly like yours, which may care about a very high level of precision, they usually have the eventing model where they want a very precise level of data. Any more questions, please?
In the reference design, do you have a tablet that's Windows certified? Does it have to have a quote-unquote real GPS, or does it just rely on mobile broadband?
Good question. So does the Windows tablet require a real GPS in it, or would mobile broadband be sufficient? What we are doing, and actually I know Sandy and Dino have been discussing this at length, what we are looking at is where mobile broadband is present. We want to optimize the experience because we perceive users will be using the system outside quite a bit. And within those geographies, we really want to give like a 10, 15 meters level of accuracy. So people can walk down the street, find the Starbucks coffee shop. If it is trying to figure it out based on other cell towers and cannot get to that level of accuracy, it's really the level of accuracy we care about. If it gives me a 200 meters level of accuracy, it really doesn't help solve my problem. So to answer it, yes, we are looking for a GPS.
In the hardware design, the Windows 8 tablet, does it have to have a hardware-wise GPS? That's, a true...
Sure. So the best way I can answer it is we see it from software. We really can go and prod the bits to find out, is it a real true GPS, talking to satellites or talking to cell towers or talking to something else?
No, but to be a Windows certified, like for them to produce it.
Right.
A tablet, will the hardware have to contain that?
Yes, it will.
Okay.
And it will. And what we'll do is we'll look for a level of accuracy that is in the 10 to 15 meters range. Whatever technology can provide that, we'll be happy with.
In fact, Fred, if I could add to that,
sure,
just and actually, when you look at the Windows certification requirements and the hardware requirements that we have up on our documentation site, you'll see that what we've actually recommended is that you actually have your position engine down in hardware. We recommend that it's not done up in software. Again, as in other talks we've talked, we want to push down to the lowest level possible, strictly around power reasons.
Yes.
So you talked about some of the sensor scenarios, like in the basic mode where you have certain events like rotate, flip, and shake. What if I want to know if the device is moving, like instead of motion, no motion, turn, no turn kind of event that we can center, so that if you're a GPS provider, we can plan positions if you're in a light and you know you're not moving, the event is coming from some of these sensors. Or do we have to do all the calculation ourselves, or can we just register for motion, no motion kind of events?
It's a very good question. Let me try and summarize it. There are certain basic gestures or scenarios that are supported by the sensor stack today. Can those be extended to cover other things like motion, as you were saying, like human walking or motion like that, so that applications have to do less programming in themselves? What we wanted to do is we wanted to take a first stab. And for the first stab, we wanted to see which is the broadest set of gestures that are applicable to most, if not all, applications. So we started with those first three. If we think about it, it's actually very little that the application does have to do to sense motion. If you think about it, the curves are really not that complex. So yes, we are bubbling it up to the application to do that work, just because for this release, we don't think we'll be able to capture every single one of those scenarios. The motion, the walking are all examples. Sitting up, getting up are some other examples that we have thought about, but we're leaving up to apps to go through and put in their secret sauce for right now. Any more questions? We still have 5 minutes, guys. Yes, please.
For the flight mode, would there be any different levels of flight mode? Because unlike Wi-Fi and broadband, GPS is a receiving only yes. So it doesn't interfere with other devices.
Good question. So let me repeat the question. Are there levels of flight mode because GPS is more of a receiving technology than a broadcasting technology? There were members on the Microsoft team who worked with the different government agencies, the flight agencies, and found out that it is important for GPSs to be turned off, even when the flight mode switch is turned on. We tend to think that it is more of a receiving technology, so it shouldn't interfere, but the law states in certain airlines or in certain countries that it needs to be turned off. So we are honoring that for right now and saying if you do provide a driver, please provide the functionality for flight mode so when the user flips it, it turns off automatically. However, with that said, if a user wishes to change that functionality and turn it back on again, it is very simple. And I can show it to you with like a couple of clicks, you go through and turn on just GPS at that point in time. So we allow for both.
I don't know if we necessarily encourage that behavior, but
I said allow. I didn't say encourage. All right. Thank you very much for your time. We really do appreciate your coming over to this Chalk Talk today.
Yeah,
We
thank
will
you,
be here.
everybody.
Thank you. We will be at the Ask the Experts. So if you do have questions, you can come over there. I don't know if we're the experts here, but come over there and we'll answer the questions for you. Thank you very much.